Hey guys, welcome to another one of our supplemental React sessions. And today we're going to be talking about how we can improve the performance of our React apps again. And we're going to talk about the different steps we can take to improve performance and what exactly is the concept of memoization, which is one of the ways we can improve performance and when we should use it. So first, let's take a look at something we looked at in the past, which is this page here. And what this page is that it is three different pages that all do exactly the same thing. What it does is that we listen to the width and the height of our component, and accordingly, we listen to and we change it on the screen, like so. And we talked about that with the global state management and passing down things across multiple component trees, there are three main ways we can do that. You can use custom hooks if the content is repeated. You can use context to pass things down inside of our little component information cloud, like we talked about before. And we can use prop drilling if we want to have linear flow of information from the parent tree to the children components within the tree. And we also looked at the JavaScript and React profiler to see how many times do we have to unmount, remount, and re-render things. And so let's try taking a look at the JavaScript profiler, React profiler stats for all three of these pages so we can see the differences between them and just how better custom hooks is and seeing the performance of all three of them. First, let's take a look at prop drilling. And let's try pressing the profile button like so. And what you can see is that when I'm changing the screen to go in and out, it is getting re-rendered. And what we can see is, let me move the profile more this way. Yeah, we can see that inside of the prop drilling page, it says it did not re-render, but the intermediate component, which is this gray one here, is forced to re-render because it is the one that is holding all of the state variables. If you want to take a look at the code over here, prop drilling page, there we go. Inside the prop drilling page, we can see intermediate component one is the one that is holding all of the state variables with uState. And so whenever the window width and the window height changes, this gray component has to change, even though it is not the one that is using the window height and the window width variables, but its children are. Now let's take a look at use context and see the performance of this one. Let's see, move in. It looks like it is not updating. Let's see why. Now it is. Okay, perfect. Nice. And now let's take a look at our page. If you look at the profile again, we can see that the window provider and the context provider has to update multiple times. And one thing we talked about with React context is that whenever this upgrades or whenever this updates, everything else has to update within the context provider. So the entire component tree is forced to re-render when something in the context changes. And you can see that on the right with lots and lots and lots of re-renders that are pretty relatively long, like a millisecond, 0.7 milliseconds, so forth. And finally, let's take a look at custom hooks. And the way that we did this with custom hooks is that we said, hey, I am going to look at this, and I'm only going to use the window width and window height from only within the green component by changing all of that separate state logic and putting it into another function or a custom hook and just using it inside of the function. So let's take a look and see with the profiler how it stacks up against the other ones. Nice. We're just going to be moving the height and width up and down. And we can see, we want to look at the intermediate component and see how many times it has re-rendered. As we can see here, intermediate component one, or this gray component here, did not have to re-render because it did not care about the window width or the window height, and only its son and daughter's components did. And we can see that inside of the code here, where we pass in the prop custom hook page, we can see that intermediate component one doesn't use our custom hook, because only its children care about it, and they are the ones who call the custom hook. Perfect. Now, we were able to see that custom hooks were really helpful because we didn't have to care about it from within the window with custom hooks page. We didn't have to care about it within the page, so we were able to pass it only to its children components. But let's say we wanted to conditionally render something on our page, like so. Let me just try adding something really quick into our code, custom hook page. And we can see here that I have a little component called display when wide. And what I want to do is that when our window's width, like so, remember this is the custom hook that we made last time. And whenever the window width is greater than 800 pixels, we want to showcase, whoops, my bad, this is the wrong one. Whenever the window width is greater than 800 pixels, we're going to want to showcase this display when wide component as well, which will say, hey, looks like you have a wide page. And we're going to use this for conditionally rendering. So, and let's take a look at what happens now inside of our code. Inside of our website. So you see here, when the width is greater than 800 pixels, it says wide page. And when it's less, it doesn't say wide page. Now, let's take a look at the profiler and see, did this change anything? Are more things re-rendering than necessary? And so on. Let's take a look. All right. So let's take a look-see. What we see here is that we have our custom hook page. And what we can see is that the custom hook page itself has to render multiple times, if you can see on the right side of my screen here. Yeah. And like now I might be thinking, why is it rendering so many times? Even though we don't use state, or we don't use useEffect inside of our custom hook page. And that's because all of the useState and all of the useEffect logic is bundled up inside of our useWindowDimensions custom hook, like so. Let me open it up real quick so we can take a look-see. Custom hook. It is inside pages, shared logic.tsx. Yeah, what you can see here is that inside of our function that we made, useWindowDimensions, we can see that we have set up the state logic and the useEffect logic all within our hook. And that is why, even though we don't explicitly call useState, useEffect, this has to re-render multiple times. And now we're going to see, hey, is there a way that we can make it so that we don't have to re-render the entire page when we want to conditionally render this wide page component here? Is there a way that we can do that? And the answer is yes. So now we're going to be looking at, hey, let's say that this is a really, really big page with like multiple different sections. And the way that we can decide whether or not we have to restructure our code in order to stop unnecessary re-renders is that we have to analyze it and be like, okay, what is happening on the page? So let's take a look at this wide page thing that we have here. What else inside of our page depends on the window width and the window height? As we can see here, this children component cares about it, but it uses the custom hook. And this children component that uses it also uses a custom hook. And we can see that this wide page is the one that cares about the width of the page. But the rest of the page, like this entire custom hook page, if we had a lot more content, doesn't care about it. So let's see how we can change our code to reflect that. Instead of conditionally rendering window width greater than 800 and then showing display when wide from inside of our custom hook page, we can instead move this logic of determining the window width and move it inside of display when wide. And let's take a look to see how that would look. So if we change display when wide here, and now at first we see that, oh, it doesn't do what we want, even though the page isn't wide enough, we still are feeling that. So let me change this real quick so we can showcase that it is a different component by adding this in. The class name. There we go. And then, so now what if instead of putting our window width use window dimensions hook logic inside of their main page, which could have, we could have so much more things that like we don't want to re-render. We can simply move our logic inside of display when wide, like so. And then when inside of our return statement, this is where we decide whether or not to display it. So the way we can do this is with a ternary for conditional rendering, where we can say like, is the window width greater than 800? If it is, we're going to showcase our even component, else we're going to show nothing or null, like so. And what we can see is that by moving our logic from custom hook page to display when wide, and you can see that it still works like so. If I run the profiler, we can see that the custom hook page itself is not forced to re-render. And the only thing that we have to re-render is display when wide. And if you remember, this is actually kind of better from the performance standpoint, because if you remember from earlier, when we moved the custom hook page rendering logic from display when wide back into custom hook page, we had to re-render the entire page itself, which took sometimes like 0.6, 0.7, 0.5 milliseconds, as opposed to now, the only thing we have to re-render is display when wide, which takes barely any time, 0.1, 0.2 milliseconds. So it's a lot more efficient with our re-rendering stats. Nice. So this is an example of code restructuring. And while this seems like a really small change, it can actually help a lot in performance if we have a page that really relies on logic and that you don't want to have to re-render the entire thing every single time. And for an example of where this is really helpful, you can take a look at one of our other learning labs, Bias by Us, because Bias by Us, what they do is that they have this really similar logic of, you see here, they have a progress bar on the left that gets re-rendered depending on if the window width is long enough or not. And the thing is, if you have a lot of things on your page, like let's say you have so many things happening, right? And you don't want to have to re-render the entire thing whenever the window width changes. What we did is that we moved the logic for determining whether or not to render the bar from conditional ternary, from conditional rendering, like so, that we looked at in the past, which would be like this. It would be like window width greater than 800 and display when wide. We changed our logic from that to doing it with this perspective of saying, hey, since display when wide is the one that cares about it, we're going to have that be the one that listens to the stateful logic and return either the component that we want or null instead. And this is really powerful because it says like, hey, it's a really easy way for us to change our code, and it also gives us a lot better performance as well. However, the problem is that not in every single case, we can just simply use code restructuring to solve our problem. Like, let's take a look back at our code base again. As we can see inside of our code base, the reason why we were able to restructure was because only display when wide cared about this logic. Now, let's say we wanted to add another thing in, right? Let's say for instance, that we could only call window width, window height from within the custom hook page because it relied on other state logic within the page as well. Let's just say that, for instance. If that is the case, we are going to need to put our window dimensions logic inside of our custom hook page. And now the question is, if we have to put our window width inside of the custom hook page, is there a way to make it so that we don't still have to re-render everything multiple times if like things don't need to change? Like the problem, as we can see here again, is that the custom hook page has to re-render every single time the window width changes with a current implementation. And the way that we can fix that, in fact, is through memoization. And the technique of memoization is basically exactly our issue right now, where we don't want to have to re-render components. You don't have to do expensive computations that take a lot of time, like here. An example of expensive computation, like we talked about, is re-rendering big or expensive components, or computing and calling expensive functions. And in React, there's a lot of different ways that we can do memoization with react.memo, use memo, and use callback. But at their core, they all do the same thing. They cache the data that we're trying to memoize, and it avoids re-rendering the cache content until one of the dependencies that it cares about changes. So now let's take a look at 3 different ways that we can use memoization: react.memo, use memo, and use callback. What react.memo is that it's a higher order component that allows us to memoize React components themselves. Use memo is a hook that we can use inside React components, which will memoize the values returned by functions, or we can also use it to memoize components themselves if they are functional components. And finally, use callback, which is another hook that we can use to memoize the function themselves. If use memo is used to memoize the values returned by functions, use callback is used to memoize functions themselves. And like in the past, when we talked about object.isComparison, this can be really helpful because with React's diffing algorithm, it determines whether or not something should get re-rendered by determining if it is equal to something else or not. But the problem is, whenever React re-renders a function, it generates a new address for the function, which means that it'll have to re-render. And use callback is a way that we can change it so that if there's a really big function, whenever a component re-renders, we don't have to rebuild it. And it's not going to be that used that often, so we're not going to go over it, but I think it's pretty interesting. So that is just one of the use cases for use callback. All right, now back to react.memo. So like we talked about, react.memo is a way for us to prevent re-renders inside of a component's dependencies. And at its core, it acts really similar to the use effect hook. And let's take a look at the use effect hook again. What we can see inside the use effect hook is that what it does is that it takes in 2 arguments. The first one is that it takes in a function that you want to call, and it takes in an optional dependency array. And what this optional dependency array does is saying that whenever any value inside of this array changes, we are going to call this function. And react.memo works really similar to this. And it combines the two inside of a single argument, a React component. And instead of listing out the dependency array, like inside of useEffect, it determines whether or not to re-render the component by checking its props. And if any of its props change, then it will re-render the component. Yeah, so as it says here, in other words, the memoized component will only re-render if its prop change or if a custom props equality check function you write is not the same, if they're not the same thing. And so in our cases, we're going to only use primitive data types sometimes, but sometimes if your props are complex nested data types, like we talked about with use reducer, and object in JavaScript, stuff like that, if you can't simply check the value stored because it passes in by address as opposed to value, then what you're going to have to do is that you're going to have to write your own custom props equality function like so to determine whether or not your component should re-render. So now that we talked a little bit about how memoized components work, let's talk about how we could actually make a memoized component. So let's take a look at this example here. And when we are making memoized components, what we have to do is that we know that it takes in 2 arguments. First one we said is the React component, which we're memoizing, and its second optional argument will be a props equality check if you can't simply use shallow comparisons. And for reference, if we want to remember what shallow comparisons are, we can take a look at one of our previous modules. I think it's over here, where we talk about object referential equality and how different types are in JavaScript, how their address is stored, and so on. And the spread operator to see how we can make deeper copies as opposed to shallow copies. And that's there if you want to take a look at it. So let's go back into memoization. And yeah, so we said that it takes in two arguments. First is the React component we are memoizing, and second is the props equality check. So what we can do is that when we are making memoization, we first pass in the function or the component that we want to memoize, and then we pass in an equality check. So let's try doing that inside of our code. Let's find it. Here it is. All right. So we have our code here, custom hook page, and let's say, for instance, we had to call window width from inside of a custom hook page because of, let's say, for the sake of this example. And what we can do is that we can create a custom hook. I mean, not custom hook. We can create a memoized component to do this. So first, we have to create a higher order component. Let's see. Let me change this again. Let me go back to our screen. Where is it? Yeah. So what we want to do is that we are going to make a custom component to handle this, and it's going to be a memoized component version of our custom hook page. So first, we're going to need to make a parent component, which will handle all of the state logic. And the reason why we're making a higher order component to handle all the state logic is that by using React Memo, we don't have to re-render so many things at once. We're only going to have to re-render a very small component, very lightweight component, which can be really helpful for us and a lot more efficient in the long run. So let's try doing that. We have to change our custom hook page to be a higher order component. So we're going to grab the window width. Then inside of here, we are going to return a memoized version of our custom hook page content. Very similar to how when we were using React context, like here, we had to make a parent component that handled all of our context with a window context container. Very similar with a window provider that we pass in. It's almost the same thing. So looking back here, we have const window width equals use window dimensions. And before we make the rest of our parent component, first we have to make our memoized function component. And we can do that like so. So we're going to call it whatever you want. Let's say this is our memoized custom hook page content. And what this is that we are making a react.memo. And inside of our memo, remember that it takes in 2 arguments, but we're only going to use the first one because that's required. And the first argument we need to pass in is the function component that we want to memoize. Let's call it custom hook page content, and it's going to take in some props. First, let's decide what kind of props do we want to do. Since like within our custom hook page with a wide page, it seems like it's a binary true or false whether or not we want it to display. So let's change it and pass it in as a Boolean. And let's make our TypeScript interface memoize props. We're going to pass in a should display wide or something. It's going to be a Boolean. So props, it's going to be memoized props. And then now we just have to simply make our React component like we normally would. We can do it like so. Turn div, like, let's just copy and paste our code here again. Okay. Yeah. So we have our code here. And now we also want to change it a bit so that display when wide, we're going to display when wide only when the props that we pass in is should this. So when should display wide is true, we want to showcase our display when wide component. So let's add that in. Nice. So we have our memoized component like so. Oh, whoops, there should be props that should display wide. There we go. Props that should display wide. Like so. So now we have our memoized function. Now that we made a memoized function, we can now finish the rest of our higher order component custom hook page that will use a memoized content. And we can do that like so. We are going to return, and inside our return statement, what we're going to pass in is just the memoized function that we just created. So we're going to return memoized custom hook page content, and we need to pass a prop down into it. And our prop is going to be should display wide. It's going to be should display wide then set equal to if the window width is greater than 800 or not, which is going to be a Boolean value. And now let's take a look at our code and our website and see how the performance has changed now that we have made a memoized component. Let's look at our profiler, and let's not try to trigger the is wide change. Now that we haven't triggered is wide, let's take a look and see at our profiler. What we can see is that it says here custom hook page content did not render. And that is because since we memoized it, we remember that we only re-render memoized content if the props passed in change. However, because here the props that we pass in is a Boolean that only gets changed whenever the window's width goes over 800, in that time, it never went over and the props never changed, which means that everything inside of a custom hook page content did not have to re-render. Only the son component and daughter component had to re-render because they used the use window dimensions custom hook that we made. And what we can see is that instead of since the memoized content of the page did not have to re-render, we only had to re-render very, very small things. Like you can see here, it says, oh, a re-render less than 0.1 milliseconds. A lot less time needed to re-render because everything else was memoized. And you can see that it was memoized because it gives you these little black bars inside of our JavaScript and React profiler. Perfect. So now let's take a look-see again and see how it would look when we do change the use window width to true. So let's say that we change it to be greater than 800, like so. It says wide page, We close the back. Yeah, stop the profiler. And what we can see is that the custom hook page content, which is our memoized component, only had to re-render twice the entire time we did this. Yeah. So instead of having, so unlike in the past, when we did it before, let's try commenting this out and going back to our original code. We see that with our original code, when we did this, the custom hook page content had to render every single time that something happened. Let's take a look. Every single time the window was changed, we had to re-render the entire custom hook page content. But with what we did with a memo, we didn't have to re-render it because it was memoized and it cared about like, hey, I'm only going to re-render when the window's width goes greater than 800. If it doesn't, I'm not going to re-render, which is perfect for a use case. Now, while we were talking about how optimization seems really, really nice, the question then arises, why don't we just do this every single time we have props anywhere? And the reason why we don't always use memoization is because optimization never comes for free. The way that memoization works is that when you make a memoized component, a memoized function, you have to store that memoized version somewhere. And the way that we do that is by caching it inside of the memory. And by that, we mean that if you take CS33, we talk about all the different types of memory and how expensive sometimes memory is to access. And we know that sometimes it's not always the best idea to be storing something inside of memory. And whenever memoized component re-renders, we have to garbage collect and remove that function that's in memory. And we're gonna have to put a new copy of the new memoized component that got re-rendered into memory as well. And this constant deletion and insertion into memory can get very intensive, which is why, like, if you see here, like, let's take a look. Every time the custom hook page re-renders, it takes like what, 1.1 milliseconds, 9.4 milliseconds, crazy. And then if we go inside and change it back to our hook, not hook, but into our memoized version of our page. So normally it takes like 0.6, 0.7, 1.4 milliseconds on average to re-render. And if we try doing it now, the memoized version, we see that when it does in fact re-render, sometimes it takes a while. I think it's not as severe in this case, but because the page doesn't have that much content. But if for a bigger page, like let's take a look at this one that we were looking at earlier, if it's a bigger page that has a lot of content that you have to memoize, sometimes you have to be really careful because you're going to have to pass in the entire page as a memoization, you have to pass it out, take it out, and put it back in. Sometimes it can get really intensive. So whenever you use memoization, no matter what, you have to always ask yourself, is memoization worth it? Is the added overhead of removing and adding to memory each time a memorized component re-renders? Should we do that? And honestly, it's kind of hard to make that decision sometimes. And that's why whenever you have to improve your React app component performance, it's always better to try to restructure your code. And only if restructuring your code doesn't work, then you should try memoization and see if it'll be helpful for your use case. All right, so in conclusion, today we talked about how we could use React dev tools to profile the performance of our React apps. And we talked about the two different ways that we can improve the performance of our React apps by removing unnecessary re-renders. First, you should always try to restructure your code and see if you can improve performance by moving around the logic that which components use. And secondly, you can use React memoization, but only if it's worth the extra overhead and the extra complexity that comes along with it. Thank you guys for listening, and I'll catch y'all in the next one.